Good morning, sir. I'm K. Vanilla. My roll number is 25955866626. I'm from CSC Department of AML D section, and course title is Applied Artificial Intelligence, and my topic title is Pros and Cons of Artificial Intelligence and ChatGPT Adoption in Education, a literature review. Now we can go through this. Introduction to AI in Education. The artificial intelligence in education leverages machine learning algorithms, natural language processing, and data analytics to personalize learning experiences. And next, the ChatGPT, based on the GPT 3.5 to 4 architecture, uses transformer models with attention mechanisms to generate human-like responses for educational queries. And next, the integration of AI in education aims to enhance student engagement, and it can automate administrative tasks and provide scalable tutoring systems. And next, the recent studies show AI driven platforms improve learning outcomes by 20 to 30% through adaptive learning pathways and real time feedback. The literature review examines technical implementations, ethical concerns, and performance metrics of AI tools like ChatGPT in academic settings. This is an introduction that AI in education leverages machine learning algorithms, and ChatGPT based on the architectures uses transformer models, and the integration of AI in education aims to enhance student engagement, and recent studies show AI-driven platforms to improve the learning outcomes, and the AI tools like ChatGPT in academic settings or technical implementation performs better. And next, technical architecture of ChatGPT. The ChatGPT is built on the transformer architecture, utilizing multi-head self-attached mechanisms to process sequential input data efficiently. And the model employs a decoder-only structure with masked self-attention to generate coherent text based on contextual embeddings. And next, the training involves pre-training on vast corpora using unsupervised learning, followed by fine-tuning via reinforcement learning from human feedback. And next, the key hyperparameters include 175 billion parameters, that GPT-3 and 96 attention layers, and a context window of 4096 tokens in GPT, that is 3.5. And next, the inference latency is optimized using techniques like model quantization and key values catching to support real-time educational systems. This is the technical architecture of ChatGPT, that it is built on the transformer architecture, and it is used to multi-head self mechanisms, and it model employs a decoder only structure with masked self-attention, and these key hyperparameters include 175 billion parameters, that GPT-3 and some of other 96 attention layers, and it is followed by fine tuning via reinforcement learning from human feedback. And it catching to support real-time education's interactions. And next, AI driven personalized learning systems. The personalized learning engines use collaborative filtering and knowledge tracking models, that BKD, to predict student mastery of concepts. Deep knowledge tracing employs recurrent neural networks that to model student learning trajectories over time using hidden state vectors. And next, the adaptive content delivery systems adjust difficulty levels using Bayesian optimization based on real-time performance matrices. And next, the AI systems integrate with learning management systems, that LMS, via the APIs to synchronize student data and learning analytics. And next, the empirical results show a 25% improvement in retention rates when AI personalization is applied in STEM courses. So these are the AI-driven personalized learning systems that engine uses collaborative filtering and knowledge tracking that and the deep knowledge training employs recurrent neural networks, and the adaptive content delivery systems adjust difficulty levels, and the AI systems integrate with learning managements via APIs. And these results show a 25% improvement in retention rates. And next, automated assessment and feedback. The natural language processing models evaluate open minded responses that semantic similarity metrics like BRT score and ROG-L. Next, the automated essay scoring systems apply fine tuned transformer models, example, Robert Tail, and it is trained on a rubric aligned datasets. And next, the real time feedback is generated using sequence to sequence models that detects syntactic and conceptual errors in student writing. And next, the plagiarism detection integrates with the AI tools using n-gram analysis and embedding based cosine similarity thresholds. That example that is greater than the 0.85. And next, the studies indicate AI grading correlates with human evaluators at R equal to 0.89 and reducing instructor workload by 40%. These are the automated assessments that the NLP models evaluate open-ended responses, and the real-time feedback is generated using sequence-to-sequence models, and the plagiarism detection integrates with AI tools using Ngram, and the automated essay scoring systems apply fine-tuned transformers, and the studies indicates the AI grading correlates with human evaluators. And next, intelligent tutoring systems. The ITS platforms combine cognitive modeling with AI to simulate one-to-one pupils using rule-based and neural network architectures. The cognitive tutors use ACT or theory to model student problem-solving processes and provide step-by-step guidance. The modern ITS leverages large language models to generate dynamic explanations and counterfactual reasoning paths, and the performance is evaluated using learning gain matrices. And next, the integration with virtual labs enables simulation based learning in engineering domains such as control systems and signal processing. This is the intelligent tutoring systems. And next, scalability and accessibility benefits. Now, first one is that AI-powered platforms enable mass customization, supporting the thousands of the concurrent users with minimal infrastructure overhead. And next, cloud-based deployment using Kubernetes and microservices. And the multilingual support is achieved through multilingual BART and the translation of APIs, broadening access for non-native speakers. And next, voice-enabled AI interfaces assist students with disabilities using speech to text and text to speech models, example Whisper and Tacotron 2. And the cost benefit analyses show a 60% reduction in per student instructional costs when AI supplements traditional teaching. This is the scalability and accessibility benefits that are mostly used for the assisted students with disabilities that which convert the speech to text and the text to speech for the disabled persons, and it can support the multilingual translations. And next, bias and fairness in educational AI. The algorithmic bias arises from the skewed training data, leading to disparate performance across demographic groups. And the fairness matrices such as demographic parity differences and equalized odds are used to audit AI models in grading and admissions. Debiasing techniques include adversarial training, rewriting of samples, and the ChatGPT has exhibited gender bias in career-related prompts, assigning stereotypical roles with p less than 0.01 significance in control studies, and the regulatory frameworks like the EU AI Act mandate transparency and bias mitigations in high-risk educational applications. And next, data privacy and security concerns. The first one is the student data processed by AI systems must compile with FERAPRA GDPR, and the end-to-end encryption and differential privacy techniques, example differential privacy, are applied in to safeguard learning analytics. And the secure multi-party computations enable collaborative learning analytics without exposing raw student data. And next one is the institutional audits reveal 30% of EdTech platforms lack adequate data governance policies, increasing breach risks. The next one is over reliance and cognitive offloading. That includes the excessive dependence on AI tools may lead to cognitive offloading. And the study shows a 15% decline in manual calculations. And the metacognitive erosions occur when learners accept AI generated answers without verification. And the pedagogical interventions such as reflective prompts and AI transparency logs are recommended to mitigate over reliance. And the academic integrity and misuse is that AI generated content challenges traditional plagiarism detection tools, and the detection models analyze linguistic features such as perplexity, birth times, and token probability distributions. And the institutions are adopting honor codes and AI use policies. And the blockchain based credentializing systems are being explored to verify authentic student work in AI saturated environments. The limitations of current AI models or mathematical reasoning remains weak, and the context window limitations restrict long-form tutoring sessions. And next, the fine-tuning for domain-specific education like aeronautics, and the energy consumption of large models that raises sustainability concerns in academic deployment. The future research agendas or develop hybrid neuro symbolic models, and next investigate federated learning frameworks, and next design explainable AI, and next explore continual learning techniques to enable AI systems to adapt to evolving curricula without catastrophic forgetting, and next to establish standardized benchmarks for evaluating AI tools across cognitive, affective, and ethical dimensions. The conclusion and strategic recommendations are AI and ChatGPT offer transformative potential in education, and however, technical limitations, ethical risks, and pedagogical challenges necessitated cautious research informed adoption. Institutions should implement AI governance boards, conduct regular algorithmic audits, and next, curriculum redesign should integrate AI as a collaborative tool and emphasizing critical evaluation and human AI co-creation. And the future success depends on interdisciplinary collaboration between computer scientists, educators, and policymakers to ensure equitable and effective AI integrations. Thank you.